So in our previous sessions, we have started with what do you mean by assertions and where are you going to use and how you are going to use these assertions and all. Let me share my screen 1 second. So basically, we have started with the introduction of what do you mean by assertions and where are you going to use this assertions and how exactly you're going to write down this particular assertions and who is going to write this assertions and all we have discussed in our previous sessions, right? Now, in this particular session, let's move forward and let's discuss event scheduler and let us also try to understand what do you mean by immediate assertions and all, right? And where are these assertions are being executed in which region and what is the importance of each and every region, and right? And give me a second. What happened to this? 1 second. Now, coming to this particular event scheduler, which we are going to have in SystemVerilog, these are the different regions which we are going to have in SystemVerilog, right? So the very first region we are going to have over here is prepone region, and next followed by pre-active, active, and inactive. These are the regions. So active region we already have. Inactive region also we were having in Verilog, and this pre-active region and pre-NBA region were added in our SystemVerilog, and prepone region and observed region, reactive region, re-inactive region, and postpone region. So these are the different. Yeah, Jitendra, any queries? Okay. So these are the new regions which were added in system development, right? And this we are going to discuss, and what are these particular regions we are going to discuss over here. And yeah, okay. Now, let's see what is this particular region. Now, and in Verilog also we have discussed about this event scheduler in a great detail, like what do you mean by Verilog event scheduler? Now, if I want to refresh those particular things over here, see, if you are going to run any particular program or if you are going to run any particular code, then your code or the compiler is going to execute this particular events. So it is going to execute this prepone region, active region, and inactive region. So for every time slot, for every time unit, you are going to have this particular events that have been created. For example, if I'm going to have a simple initial block like this, initial begin, A is equal to 0 and B is equal to 1 and hash 2, A is equal to 1 and B is equal to 0. So over here for this particular time slot, one event will be created, and for this particular time slot, another event will be created. So like this, for each and every particular time slot, a event will be created. Okay, so please mute your mic. Yeah, give me a second. If you're having any queries, you can unmute, or otherwise, please mute your mic, or else it will. So like this, we are going to have different regions which will be created in our code. So for every particular region, these are the events which are going to be executed. Now, coming to my prepone region, it is a very first region which we are going to have, and it executes at very start of a time slot before anything is going to change. So in this particular region, the signal values reflect the end of previous time slot, and this is used by the system log assertions for sampling the signal values in the case of our concurrent assertions. We will discuss like what do I mean by concurrent assertions and all. But if you want to remember, you can remember that this particular preport region is going to use it for sample the stable values. It is basically used for sampling of stable values, right? So whatever the value you want to check for the assertion, first of all, you need to sample that particular value, right? So sampling of stable values will be happening at prepon region, right? And so signal values are sampling over in this particular region, and there is something known as dollar sample, which captures values here. So this is why SVS is stable, glitch-free data, right? So here SVA sample inputs in preponed region, and this never affect the current cycle changes. So whatever the current cycle changes are there, that will not be reflected in the preponed region. Basically, preponed region is nothing but it is going to sample for the previous time slots stable values. It is going to sample it. Okay. Next, we are going to have something known as pre-active region, which is basically for an internal scheduler region, and we are not going to access it, and we are not going to check what is present in that. Next is active region. Basically, this active region, we are going to execute our always blocks, initial blocks, and you can see of assign blocks and dollar display statements will be executed in this particular always block, and left RHS of your NBA non-blocking assignments will be evaluated, and not assignment, just evaluation of RHS of NBA. This and all we have already discussed in our Verilog sessions in great detail, so you can also rewatch there. So this is what your active region, and inactive region is basically going to execute. I mean the hash zero delays, and we were not using them in our Verilog because it is going to give us race conditions. So basically, whatever the hash zero delays we are going to have, this will be evaluated in inactive region, and I will let you know like how exactly this inactive region is helping us for session failures and all. And followed by next is observe region. So this is a very important region we need to discuss over here is observe region. So observe region is where your assertions are being evaluated. So assertions, whatever the assertion we are going to write down. So for example, this is one of the assertion we are going to write down. What is this particular assertion? The meaning of this assertion we are not going to care, that we are going to discuss in our next sessions, right? Now the evaluation of this particular assertion is going to be happening in the observe region. Okay, so where the properties or the assertions are checked using the values which are sampled in the prepone region. So whatever the values you are going to sample in your prepone region, the evaluation of those particular values, whether it is correct or whether it is wrong, those particular evaluations will be done in your observed region, right? And these are the regions up to now. Is it clear? Any doubts or any queries? Inactive region, prepone region, active region, observed region. Is it clear? Any queries or any doubts here? Okay, hope everything it is clear now. Yeah. Now, next is pre-observed region that we are not going to consider. And next is reactive region. So, whatever the evaluation is done in our observed region, for that we need to get some result, right? Whether the assertion is passed or whether the assertion is failed. That particular result will be given inside your reactive region. So, the reactive region is going to give you basically pass or fail message, right? So, there will be something known as action blocks and all. We will see what do you mean by action blocks and what is it, and we are going to see. But remember that this particular reactive region is going to give you the result of the assertion which was evaluated in the observed region, right? Next is postpone region. So again, this re-inactive region and this and all we are not going to discuss, and which is rarely encountered in practice. Next is postpone region. So basically, postpone region is for reporting. Like if we want to display something like using dollar monitor or dollar strobe or SVA coverage reporting, everything is going to happen in this particular postpone region. So where no signal changes are allowed, only this is for observation and logging. That's it. So this is how your assertions are being evaluated, and these are being the messages are being executed and all, right? So over here, observed region are being evaluated, and here you're going to get your pass or fail messages, and this is basically used for displaying dollar monitor or dollar strobe or whatever the system tasks you are going to have, in which we have discussed in Verilog also. So that particular task like dollar strobe and all will be executing in your postpone region. So this is how, and this is what a particular system Verilog event scheduler is going to look like, right? Now, let's try to understand what do you mean by an immediate assertion. Now, before going to discuss about this immediate assertion and all, first of all, how you're going to write down an assertion is very important to understand over here. So let's say suppose if I want to evaluate a particular condition whether it is true or whether it is false, I'm going to use a keyword which is known as assert. So if I'm going to write down this particular keyword assert, this is going to check whether whatever the condition which I've written here is true or is it false, whether this particular condition which is present over here is true or false. If it is true, it is going to get a pass message, or it is false, it is going to give me in the console that this particular condition is false. And over here, assert is a keyword which I'm going to use for evaluating this particular whatever the condition I'm going to have. Right now, so in this particular assertions, we are going to have different kind of assertions, and the first one over here is immediate assertions. Now, immediate assertions are used to check conditions instantly at a specific simulation time. For example, if I want to check whether a combinational logic is true or not, for example, assert a logical AND with B. This particular logical AND operation is happening true or false. That means in this particular case, A should be 1. At the same time, B should also be equal to 1. If this two conditions are equal to 1, that means if A is equal to 1 and B is equal to 1, then this condition is true and this assertion will be passive, right? And if any one of this is equal to 0, then this assertion will be failed. So this is an instantaneous check. For example, let's say if I have another condition like if A is equal to 1, then after next 5 cycles, B should be equal to 1. This includes some kind of delay and some kind of delay cycles, right? So this kind of checking we cannot do it with immediate assertions. Immediate assertions can evaluate the condition at a particular single point. If you are having the conditions like this, like for example, A is equal to 1, then after next 5 cycles, B should be equal to 1. You cannot evaluate this kind of scenarios using your assertions. Immediate assertions can only check the particular conditions only at a specific point, right? So this immediate assertions can be used inside initial blocks, always blocks, tasks, and functions. This cannot be used without or outside this particular blocks, right? And this can be helpful for detecting early bugs during the simulation by validating assumptions and conditions. So this is nothing but my immediate assertions, right? And yeah, this is what I was talking about. So have assert, and this is my condition. If this condition is true, then nothing is going to be displayed. Code will execute normally. But if this assertion is getting failed, then this particular condition will be executed. Whatever the condition we have written it, that particular condition will be executed, right? So this is how you're going to deal with your assertions. Is it clear, guys? Any doubts or any queries? Shall we move forward? Okay. Now, let's take an example over here. Let me open playground. Let's say if I'm going to have a module, and this module is some example, and here I'm going to have two variables, int a and b, and within an initial beginning block, if I'm going to write down a is equal to 1 and b is equal to 1, and I'm going to write down simply if a is equal to b, dollar display success, else dollar display failure. Now the same thing I'm going to write it down with using my assertion. So what I'm going to use is I'm going to use a keyword assert and a and b, a logical and with b. Okay, here also I will write down a logical and with b. So this will a logical and with b, right? And over here I'm going to write down, I'm not going to write down anything, just simply semicolon. And let me comment to this and over here end and followed by end module, right? And this is a simple code. I've just written if else block, and if A and then logical and with B, it will give success or it is going to give failure, right? Now, just let's say suppose if I have removed everything and just an if else block, just an if block and followed by else block. That's it. And let me run this. So nothing is going to be displayed, right? Let us check it out. Yes. And what is happening? Okay, it is not been written, right? Let us write this else block and let us display it. Yeah, this we have already written and we are getting an just an info message over here that is being success, right? Now let me comment to this entire line and let me uncomment to this and let me run this. Let's see what is going to happen over here. So I'm not getting anything, right? So let's say if the condition is false, let's see what is assertion is going to do. We haven't written any display message or anything, just we have written something, just we have just changed the conditions and we have written assert a and then b. That's it. I am not writing any particular display statement or anything. You can see over here in my compilation, in my console, I'm getting an automated message that immediate assertion condition fail at time t is equal to 0 nanoseconds, and it is basically showing me the line number also over here. So this is the use case of using your assertions. In the case of your if else block, you cannot basically find it out what is the exact line number, and you cannot basically check it at which time. If you want to have that time, you need to specially mention that time t is equal to percentage t, it is getting passed or it is getting filled. But using your assertion, it is only directly going to give you at which particular line it is going to get failed and which particular time it is failing, or if it is passing, nothing is going to happen, right? If you want to display the message like if it is passing, then you can write down explicitly like assert a and b. If it is getting passed, you can write down the display statement that assertion is getting passed and all that. You can write it on the own user logic. But if you're not writing anything, if it is getting passed, then nothing is going to happen. Your code is going to run smoothly. But if it is getting failed, then it is going to directly give you an error in the console that and you can see over here it is showing the severity level as error. That means it when you're going to use other tools like QuestaSim or Vivado, it will be showing in your red line that it will be considered as an error, that it's a bug. Okay, so this is how assertion is going to help us to show us where and what is the exact bug which we are going to have. Okay, and rest all is same. Assertion and if else block are almost the same. So it is also going to check the condition, that is also going to check the condition. This is a good interview question also, like what is the difference between your assert, immediate assertion, and if else block? Because if else block is also evaluating for the condition and giving the display or failure message, assertion is also going to do the same thing. Then what is the difference? If else block, it is not going to give the console as severity level as error and something. It is just going to display it. If you specify the time, it will display the time, or else it is not going to display anything. It is going to give you just a failure message. But in a huge code, you cannot, it's not very easy to find it out where exactly the bug present, right? So if you're going to use assertion, it is going to exactly tell you where and what is the exact bug which we are going to have. Is it clear, guys? The difference between your if else block and immediate assertion. Any doubts or any queries in this? Yes. Okay. So this was about your